Garlic is one of the most ancient and powerful ingredients known to humanity. For thousands of years, it has been used not only as a flavor enhancer, but also as a natural medicine, a preservative, and a symbol of health and strength. Today, in the age of modern food technology, garlic has evolved far beyond the kitchen. Inside massive, high-tech factories around the world, raw garlic is transformed into one of the most valuable natural products on the market, organic garlic oil. This oil is used in cooking, pharmaceuticals, supplements, cosmetics, and traditional medicine, making it a global industry worth billions. But how does a simple garlic bulb travel from muddy farmland to a crystal-clear bottle of organic oil? That journey begins at the source. The process starts in carefully selected agricultural regions where garlic is grown under controlled, organic farming conditions. These farms are usually located in areas with rich soil, moderate rainfall, and plenty of sunlight, as garlic requires specific environmental conditions to develop its strong aroma and high oil content. Organic garlic farming avoids synthetic fertilizers and chemical pesticides. Instead, farmers rely on natural compost, crop rotation, and biological pest control to maintain soil health and ensure purity. This is essential because the quality of garlic oil depends directly on the quality of the raw garlic used. Once the garlic reaches full maturity, usually after 6 to 8 months of growth, harvesting begins. Modern garlic harvesting is a combination of traditional knowledge and mechanized efficiency. Large harvesting machines gently loosen the soil and lift the garlic bulbs without damaging them. The plants are then shaken to remove excess dirt and laid out briefly in the field to dry naturally. This initial drying reduces moisture content and prepares the garlic for transportation. Workers inspect the harvest to remove damaged or diseased bulbs, ensuring that only the best garlic enters the production chain. After harvesting, the garlic is transported to the factory in ventilated crates or trucks designed to prevent overheating and moisture buildup. Temperature control during transport is critical because excessive heat can trigger premature enzymatic reactions that reduce oil quality. Upon arrival at the factory, the garlic enters the first stage of industrial processing, receiving and quality inspection. At the factory's intake area, each shipment of garlic undergoes rigorous quality checks. Advanced sensors and trained technicians evaluate the bulbs for size, weight, moisture level, and aroma strength. Random samples are taken and tested for pesticide residues, microbial contamination, and sulfur compound concentration. Garlic oil derives its potency from sulfur-based compounds like allicin, so maintaining these compounds is essential. Any batch that does not meet strict organic and quality standards is rejected or diverted for lower-grade use. Once approved, the garlic moves into large stainless steel storage silos or climate-controlled warehouses. These facilities maintain optimal temperature and humidity to preserve freshness. Garlic is highly sensitive to moisture, and even slight deviations can lead to mold growth or sprouting. Modern factories use automated climate control systems that continuously monitor environmental conditions, ensuring that the garlic remains stable until processing begins. The next stage is cleaning and washing, a crucial step in removing dirt, microbes, and field residues. The garlic bulbs are fed onto conveyor belts that carry them into industrial washing units. High-pressure water jets spray the bulbs from multiple angles, removing soil lodged between the outer layers. Some factories use ozone-treated or filtered water to enhance sanitation without introducing chemicals. This method is especially important in organic processing, where chemical disinfectants are avoided. After washing, the garlic passes through air-drying tunnels. Powerful fans blow filtered air over the bulbs, removing surface moisture. This drying stage prevents microbial growth and prepares the garlic for peeling. Excess water at this stage could dilute the oil extraction process later, so precision is key. Peeling garlic on an industrial scale is one of the most fascinating steps in the factory. Unlike manual peeling, which is slow and labor-intensive, modern factories use pneumatic and mechanical peeling machines. The bulbs are separated into individual cloves, then exposed to controlled bursts of compressed air that loosen and remove the papery skins. Rubber rollers and vibration systems help separate the skins from the cloves without damaging them. Optical sorting machines then scan the cloves, removing any that are bruised, discolored, or irregular in shape. Once peeled, the garlic cloves are washed again to remove any remaining skin fragments. At this stage, the garlic is pristine, smooth, white, and aromatic. The air inside this section of the factory is filled with the unmistakable scent of fresh garlic, a sign of the sulfur compounds being released. Workers in this area often wear protective masks, not for safety, but because the aroma can be overwhelming during long shifts. The peeled cloves now move into the size reduction stage, where they are sliced, crushed, or minced depending on the extraction method used by the factory. For garlic oil production, crushing is the most common approach because it maximizes the release of allicin and other sulfur compounds. Industrial crushers gently break the cloves into a coarse paste, carefully controlling temperature to prevent heat damage. Heat is the enemy of garlic oil quality, as excessive heat can destroy volatile compounds that give the oil its potency. This crushed garlic paste is now ready for one of the most critical transformations in the entire process: enzymatic activation. When garlic cells are damaged through crushing, an enzyme called alliinase becomes active. This enzyme converts alliin, a naturally occurring compound in garlic, into allicin. Allicin is responsible for garlic's strong aroma and many of its health benefits. Modern factories carefully control the time and temperature of this reaction, allowing maximum allicin formation without degradation. After enzymatic activation, the garlic paste enters the extraction phase. There are several methods for extracting garlic oil, but organic garlic oil production typically relies on steam distillation or cold infusion techniques to preserve purity and potency. In steam distillation, the garlic paste is placed into large distillation chambers made of food-grade stainless steel. Steam is introduced at controlled pressure and temperature, passing through the garlic material and vaporizing the volatile oil compounds. As the steam carries the garlic oil vapors upward, they move into a condensation system where they are cooled and converted back into liquid form. This mixture of water and oil then flows into a separation unit. Because garlic oil is lighter than water, it naturally separates and floats to the top, where it can be collected. This process requires precise control, as too much heat can alter the oil's chemical structure, while too little heat reduces extraction efficiency. In cold infusion methods, crushed garlic is soaked in a carrier oil, such as organic sunflower or olive oil, for extended periods. This method extracts garlic's fat-soluble compounds without heat, resulting in a milder but highly stable garlic oil. The choice of method depends on the intended use of the final product, whether for culinary, medicinal, or cosmetic purposes. Once the oil is extracted, it undergoes filtration and purification. Fine mesh filters remove solid particles, while centrifuges separate any remaining moisture. Advanced factories may use vacuum filtration to ensure absolute clarity. At this stage, the oil is visually inspected for color, clarity, and consistency. High-quality organic garlic oil typically has a golden to pale amber color and a strong, clean aroma. Quality control laboratories play a major role at this point. Samples of the oil are tested for purity, sulfur compound concentration, microbial safety, and oxidative stability. Gas chromatography is often used to analyze the oil's chemical profile, ensuring consistency across batches. Any deviation from established standards triggers adjustments or rejection, as maintaining brand trust is critical in the organic market. After passing quality control, the garlic oil moves into storage tanks designed to protect it from light, heat, and oxygen. These tanks are often nitrogen-flushed to prevent oxidation. Garlic oil is highly potent and sensitive, so even minor exposure to air can reduce its shelf life. Automated systems continuously monitor storage conditions, preserving the oil's integrity until bottling. Bottling is the final stage before the product reaches consumers. The oil is transferred to automated filling lines where it is dispensed into dark glass bottles or food-grade containers. Dark glass is commonly used to protect the oil from light degradation. Each bottle is sealed, labeled, and coded with batch numbers for traceability. This allows manufacturers to track every bottle back to its source garlic batch, ensuring full transparency. As the finished bottles move along the conveyor belts, they pass through final inspection stations where cameras check for fill-level accuracy, seal integrity, and label placement. Once approved, the bottles are packed into cartons, palletized, and prepared for distribution to markets around the world. From humble garlic cloves pulled from the soil to a refined, powerful organic oil, the journey inside a modern garlic factory is a perfect blend of nature and technology. Every step is designed to preserve the essence of garlic while meeting the highest standards of safety, quality, and sustainability. This transformation not only highlights the value of garlic, but also demonstrates how traditional ingredients continue to shape modern industries in extraordinary ways.